Hey everybody. Tonight we're going to talk more about absolute value equations, sort of the concepts that underlie them, and where you might see them used in real life situations. We've talked before about how absolute value is really a measure of distance, right? In our first example, we have the absolute value of x equals 6. And this says that the distance between x and 0 on the number line is 6 units. X is 6 units away from 0. In our second example, we have the absolute value of x minus 5 equals 8. This tells us that the distance between x and 5 on the number line is 8 units. X is 8 units away from 5. So what's 8 units away from 5? 13 is 8 units away from 5. If I put 13 into this equation, right, 13 minus 5 is 8. The absolute value of 8 is positive 8. What else is 8 units away from positive 5? Negative 3 is 8 units away. If I put in negative 3 into this equation, negative 3 minus 5 is negative 8. The absolute value of negative 8 is 8. So when we see an absolute value of a difference, it's telling us what the distance is between x and that number. The same thing goes for our next example. X minus negative 4 equals 5.5. This tells us that the distance between x and 4.4, the distance between these two numbers, is 5.5 units. X is 5.5 units away from negative 4. Could be in either direction. Could be to the right on the number line, could be to the left on the number line. So when we see the more general form of it, x minus a equals d, we can say that the distance between x and a on the number line is d units, or that x is d units away from a. This kind of thing shows up a lot in engineering and design, computer programming. There was actually a pretty famous example of this past year. Tom Brady, at the beginning of this NFL season, was suspended for 4 games for allegedly playing with improperly inflated footballs. The NFL rulebook states that all footballs should be inflated to an air pressure of 13 psi, or pounds per square inch, with a possible deviation of 0.5 pounds per square inch. Using what we saw in those last 4 examples, we can figure out what are the maximum and minimum pressures to which a football can be legally inflated. Here, what we're looking for, what are the maximum and minimum pressures? We can use x to represent that. If x is the maximum or minimum pressure, we know that the distance between x and 13, the difference between x and 13 has to be 0.5. We call this the deviation, and sometimes it's called the absolute deviation. This is how far away x can be from the ideal number. Here, 13 is the ideal number, and x represents the possible values. Now, this is the type of equation that we learn how to solve in class. And this is actually a pretty easy example of those equations. We know we can have x minus 13 equals 0.5, or we can have x minus 13 equals negative 0.5. To solve this equation, to solve these equations, all we have to do is add 13. We add 13 on both sides. I get x equals 13.5. I do the same thing over here, and I get x equals 12.5. So I have the maximum possible air pressure in the football and the minimum possible air pressure in the football. When I was in college, I worked in a physics lab, and this kind of thing came into play all the time when we had to work on designing and building our own machinery. Especially when we were ordering parts, we had to tell the manufacturers of the parts exactly what we needed. And we might tell them something like, a bolt that we need has a thickness of 30 millimeters, and it has an absolute tolerance of 5%. It's hard to make things exactly in the real world. It's hard to make it exactly 30 millimeters, so we usually gave people a window. And they would have to supply something within that window. So they would need to know what is the maximum thickness for the bolt and what is the minimum thickness for the bolt that they could supply for us. So they would need to do something like this. If I know that x is my possible value, right? That's the possible minimum and maximum thicknesses. The distance, or the difference between the possible values and 30, is equal to 5% of 30. Now, that's really important. The tolerance isn't 5 millimeters. The tolerance is 5% of 30 millimeters. So we got to actually use our percent equation to calculate what that would be. We can say that A equals 0.05 times 30 to find 5% of 30. And that gives us A equals 1.5. So the possible deviation from 30 millimeters is 1.5 millimeters. Now we break up our equation into two separate equations. We have x minus 30 equals 1.5, and we have x minus 30 equals negative 1.5. We solve these equations the same way. We add 30. That gives me x equals 31.5. Add 30. We get x equals 28.5. So the maximum possible value is 31.5 millimeters. The minimum possible thickness is 28.5 millimeters. All right, let's wrap this up by doing one last example, one more sort of abstract example. So this isn't a real-world situation, but it's telling us that the absolute deviation of x from 7.6 is 5.2. So it's telling us that this is the deviation. And we're trying to find what are the possibilities for x from 7.6. So our equation here should be x minus 7.6, because I'm trying to find the distance that x is away from 7.6, and I know that the possible deviation, the absolute deviation, is 5.2. So solving this isn't too difficult, but sometimes setting it up cannot always be straightforward or seem as straightforward as it might appear. So once we have it set up, though, we all know how to solve it. We add 7.6, and we get x equals 12.8. Add 7.6 over here, and we get x equals 2.4. All right, that's it for tonight. I will see you guys in class tomorrow.